Hello guys, welcome back to my channel. I am Meghana from Sri Venkateshwara College of Engineering, Bengaluru, studying fifth semester CSE. Today I am going to present about the topic which comes under the subject of ATC and which was undertaken by Chaitra ma'am. First, today's topic is NFA, Non-deterministic finite automata. Introduction to Non-deterministic finite automata. Non-deterministic finite automata are theoretical computer science models used to recognize patterns and validate input strings. NFS plays a crucial role in the study of formal languages and are an essential concept in the automata theory. Definition and characteristics of NFA. Multistate and transitions. NFAs can exist in multistates simultaneously and have the ability to transition between the states based on the input symbols. Acceptance and strings. NFAs can accept a string through the non-deterministic process where multiple paths can explode simultaneously to determine acceptance. Flexibility in design. NFS offer flexibility in design and allow the complex, non-linear and decision process, making them powerful tool in the pattern recognition. Differences between NFA and DFA. NFA allows the multiple possible transitions for the same input symbols, leading to non-determinism, capable of representing more complex language pattern efficiently. DFA. Only one possible transition for given input symbol leading to determinism. Best suited for simple regular language patterns. NFA construction and representation. States and transition. Utilizes states and transition to navigate through possible input and scenarios. Epsilon transition. Capable of employing epsilon transition, allowing NFA to move to the new state without consuming any input. Transition functions employs transition functions to define the movement from one state to another based on the input symbols. NFA stimulation and exclusion. State configuration. Determining the possible configuration of states based on the input symbols and transition. Path exploration. Exploring multiple paths concurrently to validate acceptance of input strings. Transition evaluation. Evaluating transition and considering non-deterministic possibilities during execution. Conversion of NFA to DFA. First step is subset construction. Generating the power set of NFA sets to create equivalent DFA states. Second step is state equivalence. Determining determining the equivalence of states between the NFA and DFA to ensure the one-to-one mapping. Minimization. Minimizing the number of states and transitions to achieve the deterministic representation. Applications of NFA in computer science. Lexical analyzer. Utilized in scanning or analyzing tokens in the field of compiler design. Pattern recognition employs non-deterministic decision making in identifying complex patterns. Network protocol used in analyzing and verifying the characters of network protocols and communication. Advantages of NFA. Simplicity in design. NFS can something provide a simpler and more intuitive representation of certain languages or patterns compared to deterministic finite automata. The ability to have multiple transitions from state allows the multiple constant representation of certain language structures. Corporate representation. NFS can be more compact than equivalent DFS for some languages. This can result in smaller state diagrams, making them easier to understand and analyze. Expressive. The non-deterministic nature of NFAs allow them to expect certain language patterns more naturally. This is particularly advantageous when dealing with languages that have non-trivial and irregular structures. Flexibility in choice. The existence of multiple transitions from the state on a given input symbol gives the NFA the flexible choose between different paths. This can be beneficial when dealing with ambiguous or non-sequential language constructs. Conclusion and key takeaways. NFA allows non-deterministic transitions, complex representation of language patterns. DFA or transitions are deterministic, suited for simple regular language patterns. Thank you.